Welcome back to our Scala to Spark class, and today we will talk about user-defined functions. So the big idea is that you can actually write your own functions, or what you should call them, custom transformations in Scala, or actually some other languages, but Scala is best for this. Actually, basically you operate on data, and these functions will work, or transformations if you want, they will work on each cell in your Spark data frame and perform some transformation. Basically, data comes in and data comes out, basically, right? So there will be some technical details how to register. We'll talk about that. And the next second thing is we'll move on to aggregation. For analysis functions we used also in SQL already. We'll talk about aggregation functions as well today. Okay, so let's get started. So we'll need a new data frame, and again, so something very simple, right? Something very simple. I'll start with so day, new Scala class, day 27 object, day 27. User-defined functions, right? And they're actually exactly what you would suspect they are, right? Except, well, there are some things which are not maybe as clear, right? So this is print line chapter 6 still, UDFs, user-defined functions, right? Okay, so again, I'll use my Spark utilities to set up our Spark session, right? So well, Spark equals get Spark, right? And where's my get Spark? Import, right? And I can use it. And let's say name. I'll do Sparky. I don't know. Okay, so we have Spark, right? That's a Spark session. Okay, and will we have anything else? Well, are we going to load any data? No, we're not going to load any data for now. We'll just work with numbers for now. So use something like well, I'll use called df, right? On Spark range, let's do maybe 10 on to df, right? And we'll call it, of course, we'll give a number column, right? And you'll see, of course, that if you do df show, right? And also df print schema, right? It's nothing too shocking, right? Should show that these are integers probably, right? In types, right? And it'll show all the numbers. Okay, and again, I'm using, as usual, I forgot to call it from here, and I'm running the JSON data compilation. So far, this is nothing special, right? This is just data frame. Again, no warnings, looks okay, but that's our previous one. I could stop it, of course, but let's let it run it through. Let's see, well, we are recording. Yeah, we are recording this. Yes, we are. And yeah, we had some failure with main. Let's see. Right, let's try to load a text file, which is actually not something I want to I'll just comment this out actually for now. Okay, save that as well. Right, so we are gonna load this here, run it. And where are we here? I need to, of course, I don't have a data frame here. I need to compile it correctly for previous day. And let's run it. Hopefully nothing, no other again, in this Scala projects, if you have problem in some other file, you won't be able to compile the whole project, right? So I mean, there's some ways around it, but basically this kind of forced you to deal with errors, right? At least worst case scenario, you just basically comment out the offending code, of course. So yeah, okay, so we see it's a long actually, right? So what does it mean? It's a double long integer, right? And you have numbers 0 to 9. Okay, so it's very simple. Column name is number, right? So very simple stuff. Okay, so let's define a function. And the book talks about, I think, a power function. I think so. Yeah, we'll do a power function, right? Define. I'll call power 3, right? Again, so and we need types, right? We need type. Is there going to be a double? Okay, let's do that, right? So n double, right? And we return basically double, right? And it will be n times n times n, right? Looks okay? yeah, it's just a function, of course. Print line, say 5, right? Or say, you know, 10, it should be 1000, right? The power 3 should be 1000, right? It has nothing to do with this is just regular print line power 3 10, right? Okay, so just a regular Scala function so far. Right, let's run it. I did not debug it, but okay, I loaded it in debug mode. Yeah, we didn't need the virtual. This is even slower, so it will run through. But this should basically print 1000, right? It's just a 1000 function which should print 1000. I hope so, right? It does print 1000, right? So exactly double. That's interestingly enough, there's no errors, right? Basically, we printed in came 1000, which is of course by definition it's just a regular function. It takes 10, even though it is here it's using double. We could use also, of course, long, which will also work, right? So types, you need to pay attention what type of data you're working with, of course, right? Just regular functions so far, right? So in order to work with this, we need to, right? So we need to register them, and we can use them on all our machines. So this is right. So basically, this is what we need to do. We basically need to register, right? So it's just a function. Okay, it works, right? Something comes in, something comes out. We want to run it, right? So we need to register, and this will be slightly tricky. Again, the picture. So if you were working with Python, actually the picture will be worse. So this is one of those cases where Scala is preferable, right? Using Python for UDFs is not good, right? Not as good. Basically, there's performance issues. That it's basically, well, it's one of the advantages of Scala, of course. First of all, of course, because Spark is written in Scala, right? So trying to glue different language together sometimes doesn't work that well, but it's also the issue of how Scala works, how it optimizes on a JVM, and well, Python does not, of course. So again, nothing against Python, which I like as well, but it's expensive, right? So again, so this is one of those cases, custom functions in Scala will be better. Okay, so we need to basically use this UDF and say what it is, right? We need to say type, right? And registered, basically we are registering this function, basically. Okay, so let's see how this works, right? So we are passing to this UDF, right? This UDF function, we're passing our own function, basically. So kind of weird, right? But so that's part of the functional programming, basically, right? So we'll be able to register it, right? And we can use it, basically. So we have a regular function, and basically, so we need to register. So we need to register a function, right? So this should work. Let's take a look if this works or not, right? And then we can basically use it, right? Double a UDF. I need to import it. Yes, here we go. And basically, this should be a user-defined function. So power3 do UDF. Of course, you come up with these names. Of course, these names. So names are up to you, right? Need to be meaningful, of course, right? Should be, not need to be, but should be, right? Should be meaningful. Of course, right? No, again, power3 do you. Okay. If you say UDF, of course, you mean it's not. It's you're basically using this type. Again, if you are not using Scala, it would be almost necessary to use this UDF because so you don't confuse the types. But here, of course, you can always check. Okay, it is a user-defined function. Again, for the Spark engine, it's your own function. Okay, so let's run it. And of course, here they're using select, but I'll use this column. So I have df with column, right? Right, and I can use this part here. This column, I'll call it num cubed, right? Something like this, right? And I'll use a power UDF, right? You see, it's user defined here, and I need to say column, and we call it num. I believe we call it num. Yeah, we called it num. Okay, and we have lots of brackets. Many brackets. I need to import, of course, column, right? I need to import column, and 1, 2, 3, 1, 2, 3. Looks okay, right? And then we can just show it, right? Show, right? So I'll show it, show, right? So, and of course, since it's 10, we'll show all of them, right? So let's see. So we should see all the cubes, right? And again, so again, why is this so cool? Well, again, you see the results work quite nicely, right? Again, properly. Okay, let's see what happens if we do a, let's make another one, right? Let's make a different type. Let's see what happens if we define int, right? It should also work, right? Let's try this, right? Let's do one more, right? So let's do def power 3 int, right? I'll call it, so you can say it. So n long, right? It's an int, of course, right? And long, right? Right, and it's also going to be 9 times n, right? Okay. Right, to see the difference, and I'll do Control D, of course, right? And I'll do power 3 int, right? So difference, of course, will be that this will work. There's no errors, right? Again, because these are both numbers, right? The only thing the difference will be what comes out here, right? Something, you know, what comes out of here. We'll see if this works. Of course, we'll register it. So I will register this also. Power 3 int, right? UDF, maybe call it maybe UDF. I don't know. Int UDF, maybe something like this. I would be nicer, right? And of course, power 3 int, right? And I'll do long, right? And it should be long, right? Okay. So let's add this column as well, right? We can add this, Control D, right? And I'll add this power 3 UDF, right? I'll add this one here as well. That's pretty simple, right? So we'll see if this works, right? So we should see basically show, right? Or we could also print schema, right? We'll see that it should be you know, the regular, it should be whole numbers, right? Should be like that, at least I expect to see, right? We'll see if this works actually, right? If I sorry, names, I forgot to change the name, but okay, that shouldn't be too bad. Hopefully there's no that might be a problem. We'll see if this is a problem. I forgot to change the name of this column, right? So I have two new columns, but they're both the same name, right? So we'll see. Yeah, it didn't work. It works. Well, it worked, but it overwrote. So I overwrite. I overwrote this one here with this one here, right? You see, it's all even now, whole numbers, integer numbers. Okay, so num integer, right? And again, when I say integer, of course, because long is a type of 64-bit signed integer, right? A double is a 64-bit, i.e. standard floating point number, right? So okay, so two different things. Both are numbers, right? But this is an integer. Just a very, you know, you can have a pretty big integer. 64-bit integers can be quite long, pun intended, right? So okay, did I miss something here? Oh no, everything works fine. Yeah, it works quite nicely. And yes, we see that num cubed, right, works quite well. Right, so so what can you use in this function? So anything that takes a single value, anything comes out, you can make a formula as long as you want. Right here, right, you can come up. So you can make your own formula here, right? That depends on a single variable in, you know, basically, right? So a single incoming, right? So use any math you want. Okay, so that's good. What else? Right, the book says there's a way also we had to do this so far using this syntax, right? We had to use a regular syntax, right? Data frame function. We can't use it with a string expression. We can't use an SQL, right? But we can register also as a Spark SQL function. That's even more cool. Then we can use it inside our own SQL, which is even nicer. So again, is there a special Spark UDF register, and we can do that. So let's try this, right? And we can use the same thing, right? We can use the same thing again. Okay, I didn't want to do that. I want to do this, right? Okay. We have comments on. We register basically like this: power 3 double double. Right. So on this will be register Spark UDF register function, right? And then we can use select expression, of course, or we can use even more so, right? We can use it in a regular SQL, right? Right. So this is quite nice. Right. So what's interesting here also, when you register it, right? So it's available to any other language actually. It's not just only df, right? Df, of course, I have df, right? So this should work 2 numbers, right? Or 3 numbers, right? Or 5 numbers, right? It should work, right? So I said power 3, right? And it is registered as a regular function inside, right? So it's just like when we look at our Spark SQL functions, right? Spark SQL functions, right? Here, right? Built-in functions. It's just like one of these functions, basically, right? You have, but of course, for the duration of your program, right? It's not available to anybody else, basically, just for you. Okay, it's user defined. Okay, let's take a look, see if this works, and if it works, we will also try to make a bigger Spark query, right? This is select expression, right? So we can use it here, but we'll also use it in a regular SQL query. Again, when I say regular, of course, Spark Engine SQL query, right? Let's see if this works. Yeah, it worked just fine. Okay, let's register one more, right? So it works. And I'll register also. Let's register our other function, right? With integers, just in case, right? So how would we do this? Basically, Spark UDF register, right? Well, we have to come up with name. Does it have to match? No, it doesn't have to match. But I'll say power 3 int, for example, right? And of course, I'm gonna give this function power 3 int UDF, right? No. I give it at this function here, right? And I need to say this is a long, right, and long. Okay. So what is the syntax here? So basically, we're saying this function basically registration, right? It takes, in order to register something, we need what? A name for this function, and we need to actually pass a function. So basically, we pass a function, and out comes a user-defined function, basically. We register this, right? So now we have 2 functions, power 3 integer, and let's try to use it. So we can use this, the Spark. Do we have a? We don't have a view, right? We need to register a view, right? We forgot to do that, and we register a view with. Yeah, we need to do this, right? We need to do this, right? Df create or replace view. We'll call it, of course, df table or something like that, since we use that all the time, right? Temporary view, right? And now I can do Spark SQL, and then let's do this. So select. We can do select. I'll do triple, right? I'll do triple. Yep. So select all. This is only a single number, right? Then do we need a comma? I forget now. Yeah, I think we need a comma, right? Then we need to also need the power 3 num, right? Comma, right? And power 3 int from num, right? And we could do limit, we could order, we could do whatever we want, right? And basically from df table, right? Let's take a look, right? Let's see if this works. And of course I want to show this, right? Right? We stripped margin, and we want to show this, right? Show. I'll do everything, right? Okay. So select all. First, this is basically just a num, right? Basically, I could just do num, of course, right? And let's see if this works. Okay, it worked just fine, you see, just worked just fine here, right? So completely normal, right? So, or 2 functions work, right? And again. So what will be, you will have a task for this, right? I already thought of task for you, right? The first task, right? So to do, first to do will be to do create a custom user defined UDF which converts Fahrenheit. Of course, let's see, Fahrenheit, let's do Fahrenheit, or vice versa. Okay, your Fahrenheit Fahrenheit to Celsius, right? Right, and that's all basically, right? And then do it, right? Run it, create df with you know, column temperature in, you know, temperature f, right? Or temp f, right? Maybe say temperature. I can't type, right? I can type. Create Fahrenheit also is not type. Places, yeah, Fahrenheit to Celsius, right? You know, get your own formula. I mean, I'm sure you can find Google the formula. I know you. I see we did this before in our first course, so it should be easy, right? It's column temperature with temperatures from, let's say, let's do from 20. No, let's do minus 40 to 120, right? Right, and then it's called temperature F, right? Again, register your UDF function, right? And add, you know, so then show both, create show use UDF, your UDF to create temperature C column with the actual conversion, right? Right, again, you have you probably want the double type, double incoming and double out going out, you know, double also as a return, right? You know, to be more precise, maybe you want a return, so that should work, right? So and show the column, right? So show the column, show both columns from, let's say, show both columns from starting with F temperature at 90 and ending at 110, right? So both included, right? Right, sure. Okay. Right, so I think this is pretty straightforward. Again, so you create your UDF function like we did before. Create a df using range, using, you know, using range or something else if you want. If you want, right? If you want, right? But range probably is best, right? Raise your UDF function. Use your UDF, right? And show both columns, right? Starting from 90 and ending at 110. Right, so pretty simple, right? Okay, so that I'll commit this task, right? Right, and do. Right, so I will commit this all. Day 27, UDF task. UDF exercise. There are more, of course. You can do more complex things, but this should be a good thing to get you started. Day 227. No, day 27. Okay, so then we can move on to aggregation functions. Push. How much time we have? We have 25 minutes. Okay, so we can do like 20 more minutes, and let's do move on to or right. So we can see extension, right? So okay, so before we move on, so this why this UDF is so good, because again the key takeaway is that again these UDFs they will be applied in parallel, right? You don't have to run it as your own loop, right? Spark Engine will take care of applying your function across multiple machines and all the good things that come with that. Again, in practical terms, this means, of course, if you have a data set which you can run on your own computer, you could probably do this much quicker just using a regular Scala program. Again, the Spark Engine will only really come into force when you have access to multiple tens of 20s or even 50 machines or so on, right? It won't be that useful if you have only a couple machines, of course, right? Again, so let's move on to our aggregation, right? Right. So again, so that's it's what we're using in SQL, and this it comes across. It's useful pretty much everywhere, right? We are transforming columns, right, by some usually do some grouping, right. We can just summarization, right. So right, we can also do aggregations onto multiple different on the complex data structures such as array or list or map, right? But so we can just of course do, again, we are collecting something, right, and do, well, some transformation basically. That's a big picture. So let's start a new day 27 Scala class, day 27 aggregations, right? And that extends up. Print line, chapter 7, aggregations. Okay. Now, and we'll do, of course, val spark get spark, right? And we'll get sparky, or whatever name you want. Right. For now, I'll run this. We'll use some data set probably. Okay, looks like it's working. Great. Okay, it works. So again, chapter 7 aggregations, right? So I will do the whole thing, right? So so there are other ways of doing it. There's roll up, there's window, right? Some other ways of doing, and the main thing we should remember that each grouping returns a relational group dataset. Basically, it's not data frame, right? It's not a data set of rows. It's something slightly different. But when we do our groupings, we'll be able to Scala. The IntelliJ will tell us what we're getting basically. So this key part here. So important, right? Important, right? Which we will want to transform into a data frame at some point, right? Performing some functions, transform. So that's the thing which I want to emphasize. Okay, so let's take a look. What kind of data set we're going to have? We're going to use, okay. So now we are going to cache a huge data set, right? And so our retail schema, let's see how well it works. Okay, this is we have a small volume of data in our retail data across all the CSVs, right? And let's see, here we are coalescing in the 5 partitions, I believe, right? Let's see, we're caching it. So again, what does it mean caching? It means it sits on our own computer memory when we are doing our tables and so on and so on. Let's see, can we actually live with this part here? Let's see, cache on. Let's see if we can look at our Spark utilities. Can we add one more, right? Get Spark, cache on, right? Let's do that, right? So cache on. Let's call it can we boolean equals true, right? Right, cache on. Can we do this something like this? Yeah, I think we can. Right, we have so many parameters, right? So cache on, basically, well, let's see. But it's in df. Okay, no, it's not here. Sorry, not the wrong place. but we can leave it here at least, right? This is fine. It's in our reading part here, right? This is not in Spark session. Here is fine, but here, right? So print schema true, we want here, right? Cache on. So comma. Come on. Cache on. Cache on. Right, lots of flags, right? Equals true, right? We probably want to nicely. Right, I like doing this way. There's also a formatter here built in. I don't know if you need this, right? So, and we get data frame, right? So if cache on, right? If print schema, and if cache on, of course, df cache. Yeah, okay, right. Okay, we are gonna cache it, right? So we are gonna basically cache it onto our schema. But coalesce, right? Do we need this actually? Well. Coalesce, right? This is remember what coalesce does, right? This is gives you, it has exact number of partitions, right? So I'll leave it at one part. I'll stay with one partition for now, right? I'll stay with one partition, right? We could add this. We have partitions one somewhere here, right? Where's our partitions? Or we don't use partitions here? Oh no, here. Where are partition count, right? This should also give us a view, right? And we'll see if this if it coalesces to 5. We'll see if this actually forced us to go to 5. Okay, so let's run this, right? So I'll save it, but let's do. So we have our Spark, and so let's do our df. So val df equals get read data with you, right? Right, and so we have what? Spark, right? And we need a name, right? File name, file path. And this is interesting that we are going to use the wildcard. Let's see if this works. So we are going to use this wildcard. Of course, it is data retail CSV, right? All. Let's take a look. Where is it? Not flight data, retail data here, right? All on where is it? Well, I don't have it. Oh, by day. Retail data all. It's not actually here. It's actually here, right? I guess it's just here. This is everything. Okay, it's pretty big actually, right? It's 45 megs, right? So actually I don't need. Well, okay, I'll leave it here. I guess it's using this all, not by day. I wonder if it's a mistake, right? Well, it doesn't really matter here, right? Because okay, we'll use it here. We'll use this one here, but because we're just gonna load a single file actually, right? So we are going to load a single file, right? So we can of course get this here, like pass. Where is it? Copy path reference. It is this one here. Copy from content repository root, right? So here, right? Looks good. So Spark read data with you is of course we imported, and we need of course file path, right? This is big, right? This is pretty big. So everything else is we're gonna cache to our memory, right? And let's do this. PDF print schema, right? We'll do that, and df show, I don't know, 5 files, right? Let's do that, right? Print schema, and maybe we also df show routes, right? So maybe show some print line df count, right? Yeah, count. Let's do that, right? Okay, rows. Okay. I'm lazy, so I don't want to do that. You can do, of course, string formatting here. Okay, so let's run it. See if this will work. I did not do coalesce, right? This would create 5 partitions, for example, here, right? So I forced in a single partition, single huge partition. Again, this is not really that big a data, 45 megs. I mean, it used to be big data, not anymore, right? It was maybe big data 30 years ago, probably, but not anymore. Now let's see if it. Yeah, it worked fine. 500 million, half million rows, right? Nothing to write home about. Okay, it loads pretty quickly again. So actually here, of course, here, all right. And I wanted actually, that's good, but I want to do this part here, right? So this is good, but let's double check, right? Actually, Control D. I'll use this, right? Technically, single. Here it is a single file, but wildcard should still work, right? So let's test it one more time. Yeah, I remember we had some problems with wildcards, right? See if the engine works now correctly. There were some problems with this. Will it have a problem? No, no problem whatsoever, right? No, so no problem whatsoever. Wildcard does work now. I know, I don't remember what is the problem. Okay, so we have caching. We have view. Do we have view? Yes, we do. We have view called df table. Very good, very good. We didn't need to print. But I didn't need to print schema because this is already done, right? This is done by read data with view. Okay. Now, what else? So we are okay. So looks okay. Invoice stock code, description, quantity, invoice date, unit price. Okay, great. Okay. So we'll need. Why do we need all this data, not just a single day? Because we'll be doing some groupings, of course, right? So count we already know, right? So we already use this, right? So simplest method is, of course, is that right? Is the simplest, right? Right. So again, right? So method. Right, so yeah, right. So so count is technically an action, not a transformation. So it happens immediately, right? So right, so right, yeah. So for now, so if you since we're going chapter by chapter, right? So it's an action basically, right? So it happens immediately. So it's eager. It's not lazy, right? It's eager, right? Right, and it happens immediately, right? So that's kind of important, of course, right? Because well, most things it's important again because most things in Spark are lazy, right? Again, only done when really needed, right? Otherwise they just come. Otherwise we are just writing steps to transformation which Spark engine will be able to optimize, right? Optimize. All right, and of course, again, remember, again, of course, again, show, of course, is eager as is collect, right? Eager, right? Immediate, right? Immediate, right? Right, as is collect, and some other ones, right? So, but most are not, right? So that's the important point, right? So, stat functions, right? So in stat package, right? So we won't see all of them count. Again, let's do some more, right? So it's like count, of course, show. We can do it immediately, right? So what's the difference here? So difference will be, of course, that we discount here, right? So what's the difference here is that so here count is not eager, so only show is eager, right? So that's kind of important point, right? So oops, Control Z. What happens here? Right, okay. Count, so I need to import it, right? And I'm going to import it from functions. Do I have it? No, I don't have it, so I need to import it. Let's do some count. Again, it takes, so I need to import not this prefix. I want to import it directly, so I'll be lazy and I'll use it like this, right? Functions like this. Is it in stat? I don't think it's in stat. I think it's in regular, right? And stat, right? Count, I believe, right? Yep. So this is a lazy version. This is a lazy version, and then of course show is the one which actually does the actual shows the actual results, right? So that's one, right? So count distinct, right? So we want to also do count distinct stock codes, right? So let's do that, right? So I'll just keep adding them so you can do some, right? So also, right? Of course, I could do multiples, right? So count distinct, right? And of course, I need to import it, right? Here you go. And let's do some more. Approximate, right? So this is very interesting, right? So again, if you're working with a smaller data set, right? This might seem like a silly function, but this is we're working with terabytes of data. This will be an important function. Again, you need roughly, right? You need roughly, and this is, I think, is up to 10%, right? So right. So this is going to be very fast. So again, we have a right, but this should be much quicker, right? So you'll see the error will be quite off, right? So again, very interesting, right? I think we saw this, we tried this before, right? So this is very kind of funny, right? Again, we have a huge error, but I'll do less error. I'll do a smaller error actually. I'll do a smaller error. I don't like this big error, so I'll do like maybe 0.5 maybe, right? It shouldn't be as big an error, right? Or maybe 0.01. Let's see what happens, right? 0.01. Right? I don't expect to see. It should be pretty quick, right? So it should still be relatively right. Yeah. So here it's 1%, but I don't think it's going to be 1% error. Yeah. Right. So this is interesting, right? Well, okay. So I'll do 1. I'll do maybe. So 1, and we need, of course, import it. So let's read about this, right? So approximate default. Okay, default is okay. So parameters RSD maximum relative standard deviation allowed. Default is 0.5. That's very interesting, actually. Right. So how far from the relative standard deviation it is? It's okay to deviate, right? If you remember your statistics, right? Relative STD, right? Standard deviation should be in a coefficient of variation, right? It's also called RSD, right? So this is what we're talking about, right? Right. Dispersion of probability, dispersion of frequency analysis. Maybe we'll see a nice picture here somewhere, right? What we're talking about. Unfortunately, we don't see a nice picture, right? So so basically, well, there's a definition of how it is. Basically, as you can see, right? There's no standard deviation here, right? So 0, right? If you have 90, population standard deviation is 80, right? So CV will be 8.165, right? Divided by 100, right? So that's a formula, right? It was, yeah, to the mean, right? As a ratio of standard deviation, that's standard deviation divided by the mean. So that's the formula, basically, right? So you have this type, right? This is more variable. So standard deviation is 32 here because it jumps all over the place, right? On average 20.7. So this measure takes in effect takes both the mean, right, arithmetic mean, right, and also the standard deviation. So kind of interesting statistical. So this is using, right, so we don't need show, we don't need print, right, we need print line. Here, what's happening here? One more. Right. Let's do maybe 0.1. Oops. Default. It should work. Okay, here we go. Default, right? Yeah, here below. Right. Of course, same as RSD. Right. Roots. So okay. very interesting value, right? So let's see how it works, right? So let's see if we go less, right? It should be much more precise. So again, it's for statistical reasons, right? This will give you some interesting values. Okay, and we have some time. Actually, we need to finish this. We'll continue on the next. So let's run it, and then we'll do some more functions in the class. Okay, so warning, right? It's a plan of string section, right? There's a warning, but so we see, of course, that this is a true answer, right? They're distinct codes 4070, right? You can see how this is already extremely precise, right? So even this gives you pretty nicely, right? So let's see, do we want to have the other values, right? Do you want to have mean, right? So I will want to maybe jump ahead, right? So I will get first and last, of course, right? These again you might see silly, but these are also so these are based on the rows and data frame, not the values. Again, these are right. We'll get those. We'll do this and those in class. So let's do a little exercise, a second exercise today, right? So there are two exercises. Remember, the first exercise is to create a user-defined function for Fahrenheit to Celsius conversion, right here, right? That's the first to do today. And the second one will be to let's see, what kind of columns could you do? We had this is stock code. Well, unit price. That would be interesting to see, right? Stock code is good. Unit pricing, right? Maybe, or customer ID. Let's check on customers, right? On customer ID, right? Yeah, let's check on customers. So your task will be simple, right? So to do simple one, do simple task, find count, distinct count, and also approximate distinct count with default RSD, right? For customer ID and also unit price. Why not? Since too easy, right? Right. Alright. So that's pretty easy, right? Pretty easy task, right? Simple task to do. Okay. Quantity, not too interesting, right? Yeah, so these are two which would be interesting to see, right? Also, well, we could do invoice number, right? We could do invoice number. Let's do also invoice number, right, as well, right? Okay. All right, so that will be three different. So distinct count, distinct count. Of course, count. Of course, count should be the same for all of these, right? Because that is the number of rows, right? But probably not null, right? I forget now if it's null or not. We'll see, right? I think it should be. Right, number of items in a group, right? Okay. So that's it for today. We'll see. I'll see you guys at 9, Monday evening at 9, and we will continue working on aggregation functions. Thank you.